minute, this isn't Jack. This is actually Betty. She's my 4-year-old bearded dragon, and she wanted to have some fun too. But Betty, I'm gonna put you back in your habitat while I talk to my friends here. All right. See you soon, Betty. Stay nice and warm. Before I get started, I need to sanitize my hands. So, girls and boys, today it's all about volume. I want you to look really closely at my 3 graduated cylinders. I want you to observe with your eyes, and I want you to record and talk about with your classmates which of these containers is holding the most amount of liquid and which is holding the least amount of liquid. Take a minute and jot down your thinking. Okay, let's try. Let's read them. I'm going to turn the first one around. And I don't know if you'll be able to see the numbers, but as a scientist, it's important to get way down low and look carefully. This one says 100 milliliters. Okay? So is this going to be more or less than 100? The second one, this one says 100 milliliters too. I wonder what this third one's going to say. We get down low. Well, right between 90 and 110 is 100. 100 milliliters. How can these 3 containers all hold the same amount of liquid? Look at the difference. Remember, volume is the amount of space something takes up. Pay close attention to the shape and sizes of these containers. If you want to trick a family member at home, you can do this with things you may find around the house. I have these graduated cylinders, but you could use a measuring cup and 3 containers of different sizes. And I just used food coloring to color my water so it was easier to see. So remember, volume is the amount of space something takes up, whether it's a long and thin cylinder or one that was much wider with a greater diameter. Okay, scientists, I'll see you back here soon when we talk about mass. Hello, scientists. Okay, we talked about volume. Remember, that's the amount of space something takes up. Now we're going to talk about mass. Mass is similar to weight. So let's look at these 2 objects. I have a sponge and a brick, and they are the same volume or really close to the same volume. I had to do some trimming of my sponge. Let's think of the mass. They have the same volume. Do you think they have the same mass? Let's use my digital scale to check. Let's zero it out, put on the sponge. The sponge reads 1 ounce. Now the brick. 1 ounce, more than or less than? Let's see. Whoa, the brick weighs 5 pounds, 1.3 ounces. So there is a big difference in mass versus volume. Consider this. You're moving to a new home, and you are given some moving boxes. They're all the same shape and size. So you go to your belongings and you find your collection of stuffed animals. You pack 1 box full of your stuffed animals, tape it up. Then in another box that is identical to the first box, you pack it full of your books and you tape it up. Those boxes have the same volume, but do they have the same mass? Which one would you rather carry to the moving truck? In a minute, we're going to be investigating the 3 states of matter, looking at water, and comparing their volume and mass. Until then, I'll see you soon. Now that you've watched these 2 investigations, what can you tell me about volume and mass? How are they similar? How are they different?